We see plastics every day in products like shopping bags, bottles, and containers. Though useful, they're a major problem. Most plastics are created, used briefly, and end up in landfills and oceans. Even recycled plastics are often converted into lower value products like carpet fiber that can end up in the environment anyway, where they can linger for centuries. The problem of plastics is based in their chemistry. Plastics are made from tiny monomer units that make up larger polymer chains, reinforced through incredibly strong and stable carbon-carbon bonds that can make them difficult to process and break down. The Fieser Lab at USC aims to use chemistry solutions to address these problems. One method the lab is exploring is breaking down existing plastics, like the polyethylene in shopping bags. With catalysts, we can chemically unzip large plastic molecules, converting them to viable monomer units that can then be reused to make new plastics or even broken down to create new molecules for products like fuels. A different approach is designing degradable plastics. The Fieser Lab is using monomers from organic sources like soy or corn, along with those from petrol sources, and catalyzing them with customized rare earth metal complexes. This process creates plastics like polyesters, which have weaker oxygen-carbon bonds that are more easily broken apart than the conventional carbon-carbon bonds. These can then be recycled, and then reheated and reprocessed back into viable monomers to make new degradable plastics. By combining solutions to improve plastic management, we can create a system where plastics are continually reused, recycled, and remade, or even transformed into valuable fuels, removing plastics from ecosystems and keeping them within a contained, closed-loop system. Of course, there are still many current barriers to resolve. We need to think about the costs, energy effectiveness, our waste management policies, the effects of impurities like dyes on recycling, as well as the emissions and byproducts of the recycling process itself. But if we can continue to research, improve our awareness of the plastic problem, and be conscientious of how we manage our waste, we can move closer toward achieving a true, closed-loop plastic system. To learn more about plastic solutions, please visit the Fieser Lab website, which includes information about the group's research and community outreach.